Greetings to you, Dr. Stephen Mujay here, and welcome to Module 6, where I am going over securing cloud resources in this cloud computing class. And I am going to share my screen here. Okay, so we are in Module 6, securing cloud resources, as I mentioned, and we are following this CompTIA Cloud Plus Guide to Cloud Computing by Geo West. Thank you for watching and coming along this journey so far. We've completed the first five modules, and now we are on to module number 5. Let me also point out that for this module, I am going to cover the concepts, and it's got quite a lot of them. So I'm going to primarily go over the chapter or the module in this recording, and then I'm going to come back with some other recordings where I am going to be going over the specific labs. So please be sure to come back and watch the labs that go along with this presentation. These are the objectives that we have. Describe common threats to and configurations for cloud computing, secure cloud networks, and then we'll secure cloud compute resources, and then secure cloud hosted data. And then at the end, just like with all the other modules, we'll wrap things up with troubleshooting techniques in cloud security issues. Okay, so as when it comes to making the migration to move from on-prem to the cloud, there are different factors that our organizations consider, which could be cost, the expertise of the staff who are going to be managing those resources. But those are not at the top of the list that make organizations hesitate to move from on-prem to the cloud. As you can see, security is the number one reason why organizations hesitate to make that transition. And so in here, we are going to be talking about some of the popular tools that can be used to mitigate the risks associated with moving to the cloud. All right, so these are some of the common internal as well as external threats to cloud security. They include data breaches. It seems like every now and then we are getting some data breaches. We have had some include AT&T, which affected several millions of current and former customers. There's been the Ticketmaster breach. I think with the Master breach, it affected more than 400 million. Right. So these are just two examples of the many data breaches that are out there that exist. Denial of service and DDoS attacks, insecure interfaces, advanced persistent threats. These are taking place all the time. I think there is the Lazarus Group, which is sponsored by North Korea, and then there is APT34. There's the Typhoon, different APTs. These are state-sponsored threat actors who can penetrate different networks, including cloud, the cloud environment, and then gather some information. Account hijacking and poor account management. You'd be surprised that in some environments, MFA may not be configured, right? So that goes around the poor account management, user error. Insider threat is real. This is a threat that comes from employees, which is why implementing the zero-day trust is really crucial, right? So you can't really trust anyone, including the insiders. And then there is the data loss with no backups. That is a threat. Now, there are scanning tools that can be used to improve security within the cloud environment. And some of the popular scanning tools include Nmap, which can scan the network. And then Nessus can also be used for vulnerability assessment, assessing the vulnerabilities that may exist within your network. And then there is Metasploit. Metasploit that's used in penetration testing, and that can be used in the cloud environment as well. Right here, we have this image of Metasploit, and you can see that a weak password has been detected, which is 1234. So using Metasploit, you can do that. So there are many scanning tools out there, including the ones that I have already mentioned, which can perform deeper scans of networks, and then if provided, of course, with the account credentials, which is why we have the credentialed scan. It uses the credentials. On the other hand, network-based scans are applications that scan devices connected to the network to check configurations and identity network security gaps that may exist within the network. And of course, after those network security gaps have been discovered, the idea would be to close those gaps. So these can be really helpful. Some networks might also have agent-based scans, maybe on devices like a server. Agent-based scans are designed to collect some information about the device, which might be a server. So it collects that information, and then it sends it to a central location, and then that information can be analyzed. You may, you also want to be familiar with, let's see. Okay. You want to be familiar with a risk register. This is coming from project management. So it's a project management tool that can be used to document any cybersecurity risks that exist within the environment. And then it can also provide some useful information about the risks that exist within a network or within the cloud environment. And then within that risk register, you can come up with some mitigation strategies. How are you going to mitigate the cybersecurity risks that may have been identified? And then the register will also come up with plans for responding should a vulnerability be attacked, and which team members are responsible for carrying different tasks. So the risk register is helpful as far as that is concerned. Now, let's talk about some cloud-based approaches to security. There is the shared responsibility model. And in this model, the cloud service provider is partially responsible for some of the cloud security aspects. And then, of course, the customer will also be responsible for other aspects. So knowing what the cloud service provider is responsible for, and then what you are responsible for as an organization is important. And then there are two security approaches in terms of maximizing cloud security. There's the DevSecOps. With DevSecOps, it's basically based on the premise that everybody is responsible for the security of an organization, whether it's the developers, the administrators, the analysts, everybody is responsible for security. So security is integrated into every aspect. And then the micro-segregation, this allows the granular control of security for traffic and workflows within the cloud, right? So you can restrict some communications between a certain subnet within the cloud. You can create some subnets that can help in restricting some movement, right? So micro-segregation can help with that. This is a diagram showing that DevSecOps. You may also want to, the next thing that I'll talk about is shadow IT. This is a most common component when it comes to cloud-hosted applications. Some people might have some applications that they use that IT may not be responsible for, but those applications or the technologies can come with some risks. So knowing or having a plan that can address this shadow IT is important, because if it's not properly managed, those applications or those technologies can be used to share customers' personal identifiable information. So company policies should be in place to regulate, the data that can be stored or processed through those shadow IT solutions. And then also having an approved application list should be used with products that are known to be more reliable, right? So we do have a security check here. Which type of scan requires software installation on the monitored resource, right? So out of these 4 options, which type of scan requires software installation on the monitored resource, right? So have you had a chance to think about it? The response is agent-based scans. This is these are small applications that are installed on monitored devices. I did mention devices like servers. They have a goal of collecting information about that particular device. And then, of course, it's sent to a central location for analysis. Let's move on to the section 6.2 about virtual network security. Okay, so a unified end-to-end cloud security system often means relying on a cloud service providers built-in security tools. So different cloud CSPs have built-in security tools. We are focusing, of course, on Microsoft Azure. There are several security tools that are built in there that we're going to be exploring and talking about. So those built-in security tools that are provided by the CSP can help to eliminate compatibility issues. They can also increase visibility into your cloud infrastructure. You can have a better idea of the devices that exist within your network as a result of these security tools. That can also help with collecting monitoring activities in a central location. And then it scales more efficiently as business needs expand, right? So businesses are going to grow. Those tools can scale in an efficient way. All right, so we are going to take a look at some of the Microsoft Azure tools. There are some similarities. Some of the tools are going to do the same things, but what I will point is the names are going to be different. So the ones that we're going to be focusing on in here are the Azure ones. All right, so, but before we do that, let me point what some of these security platforms do. They are going to do 2 things. They are going to allow traffic into the network or deny that traffic, right? So an allow list is going to allow traffic to come through, while the either block list or deny list is going to prevent some traffic from passing through your network. So there are some security rules that must be configured on the different resources, and that can help in bringing up the availability or the availability of resources. This is how those rules work. There is, let's say there is a message that arrives. So there is a checking of the first rule, right? So that as it is checked, the questions that are asked are, does it fit the rule? If it does, then it goes on to processing, does this rule deny traffic? If it doesn't deny traffic, then the message is allowed. But if it denies traffic, if there's a rule to deny, then the message is dropped, right? But if we come up here, if the answer to the rule fitting is no, then the question is this the last rule? If it's the last rule, then the message is blocked, right? So that's the flow chart. Now, let's transition to Microsoft Azure networks. And Microsoft recommends that you establish a perimeter, which might also be that DMZ, and its function is to screen some subnets so that as traffic comes to your private network, it goes through this perimeter network or this DMZ, and that traffic is screened before it makes it into your network. And the same thing can be saying as that traffic is leaving your network going to the internet. So there are some several security devices that can be used in Microsoft Azure that can be configured to provide this particular type of protection within the VNets, right? So remember, you create your resources, and then after you create your resources, you can have the virtual network, which are the VNets, right? So you can configure those security protections and apply the rules towards a virtual network. You can apply it to resources, but it's more effective and efficient if you apply some of those towards the VNets. Now let's talk about network virtual appliance, NVA. This is a virtual machine running in the perimeter network, and that controls network traffic between the perimeter network and other subnets, right? So you can have different, you can have like the hub and spoke, and then the hub can control the traffic that is going to all these spokes, right? So that's the function of a network virtual appliance. And then third-party NVAs can provide additional security features such as providing a firewall, intrusion detection system, or even intrusion detection systems, right? So some of the third part can also provide antivirus solutions. With the Network Virtual Alliance, let me also point out that it can manage traffic as it comes into the network or as it is outgoing, and it can work at the layer number 4 of the OSI model and layer number 7. At layer number 4, it's going to be looking at port numbers. So it can allow or deny traffic based on port numbers or services. Those protocols, is it UDP, TCP, which port number does it belong to? Microsoft Azure also has the Network Security Group, NSG, and this provides firewall style. Remember that firewall style is has the capability to allow or deny traffic. So the NS group can be configured like that. Azure creates 6 default rules for every NSG, 3 for inbound traffic, and of course, the other 3 for the outbound. Those are the defaults. The rules cannot be moved or altered, but you can override them by creating higher priority rules. And then the rules are stateful. What it means is that once a message is allowed to cross the network security group, later messages in that same conversation continue to be allowed. And then we have a diagram right here showing the NSG. So there is the stateful NSG right here, which can monitor traffic as it goes to this web server or as it leaves the web server, right? And so you can see there inbound port number 80, outbound port number 80, right? So this is going to look at traffic based on those port numbers as it is coming to the network or leaving the network. Then there's also the Application Security Gateway, ASG. This is a subgroup. It's related to the Network Security Group, NSG. It allows for microsegregation of your security appliances according to application and workload type within the virtual network. That can also be, you can associate one or more appliance security groups to each of the network interface. So Azure security tools include the Azure Firewall, right? So then there is the Azure Network Watcher, the Microsoft Defender for cloud, and then the VNet TAP, Terminal Access Point for network capturing. So those are some of the options that are available in Microsoft Azure. So I'll go to this Microsoft account, right? So if I go to, I don't have any, I can go to different resources, to all resources, and then I can search for those different resources that are listed here. So there's the Microsoft Firewall, there's the Azure Network Watcher, right? So if I come actually here and I'll go to all services, we can see a lot of those under the network security, right? So there is the Firewall Manager, the network security groups, there is the firewall, network security perimeters, web application firewall policies. We'll talk about those in a little bit, right? So those are some of the applications. There is the Network Watcher under the monitoring category. Okay, but I'll go into further detail as far as those labs are concerned. I'll come back and be sure to come back and view the recording that I have for that. In terms of security, you may be supporting an organization that has on-prem and cloud presence. So there are some hybrid alternatives. You also need to keep in mind that some cloud security techniques must auto-scale, while on-prem security tools must have deep access within the network perimeter. But many of the same best practices between the on-prem and the cloud apply for hybrid and multi-clouds as for other cloud structure. So then there's a commonly used tool to bridge the gap between on-prem and cloud portions. So if you have on-prem and the cloud, this tool is the Cloud Access Security Broker solution. And what it does is it's designed to detect applications and other resources running within a domain and So it can detect those and then monitor those resources according to the policies set by your organization. Time for another knowledge check. What cloud security tool functions similar to a Wireshark, right? So if you can, if you are familiar with Wireshark, it's it can look at the traffic that is incoming, right? So the answer to that is traffic mirroring. Traffic mirroring or packet mirroring provides deeper insight into captured traffic than what flow logs offer. So traffic mirroring is similar to the packet capture and analysis functions that are provided in Wireshark. All right, moving on to the next section, section 3, compute security. Right here, typical cloud compute resources include instances and applications. And so this section will cover security techniques that can help secure those instances like virtual machines. Okay. There is device hardening with device when you first install an operating system on a server, you would need to create a hardened baseline. So that hardened baseline, it documents the configuration changes that are needed to secure the system and its operating system. What is it that you need to secure it? So that's the hardened baseline. And some security techniques to consider the plan the subnet placement. What subnet are you going to place that server or and then disable unnecessary ports and services. If you are not going to be using port 80, then disable it, or any services that are unnecessary. That should be part of the hardened baseline. Enforcing account management policies, because remember from the beginning, one of the security risks has to do with poor account management. So you do need to enforce any account management policies, and then install any EDR or any antivirus, anti-malware software, and not only just installing it, but making sure that it's updated. And then if you are using any host-based software, intrusion detection systems, intrusion prevention systems, make sure you create those. And then create single function resources. Applications also have to be secured. So not just the operating systems or the virtual machines, but the applications. Right. So this applies to software as a service applications or platform as a service components. There's security that applies to that. So there is the web application firewall. I did mention this earlier. This is a special firewall that can be used to protect software as a service, SaaS applications, and it can inspect, monitor, or filter messages as they are coming in into a web app in order to protect it. Then there is also the application delivery controller, which is a robust load balancer that can perform functions like providing granular filtering of traffic, handling encryption to reduce the load on servers. The application delivery control can also incorporate traffic shaping and monitoring techniques. Right. So in terms of this section, there is this knowledge check, which security appliance can perform encryption to reduce the processing load on protected servers. Again, the question is, which security appliance can perform encryption to reduce the processing load on protected servers? ADC. The ADC can handle encryption to reduce the load on servers, right? So that's the application delivery controller there. As you can see right here, it can handle encryption, the application delivery controller. All right, so moving on to data security. We deal with several types of data on the cloud, within the cloud. So some security measures needs to be put in place as the data travels or is moved from one point to another. So data can exist in three states. There is data at rest, which you are going to have on your storage items. And then there is data in use. This is data that is being temporarily stored in memory, secondary storage, or being used by a processor. So that is data that is being used. And of course, there is data in motion, data that is being transported between different locations. And the security should be in place to secure all these three states of data, whether it's at rest, in use, or in motion. And then there should be a data loss prevention solutions, DLP solutions, like secure web gateways. Those specifically target data in all the three states with the goal of providing a comprehensive protection, right? So some solutions must definitely be put in place so that the security of data in whatever state it's in is ensured. Encryption of data is also important. It means you are scrambling that data into a format that cannot be read as it is being transmitted. So encryption of data stored in the cloud can be performed by the company who owns the data. So if you are working for the company and you own that data, then that company is responsible for the encryption. As well, the cloud service provider who stores the data is also responsible, or by third-party encryption services. Some tasks must be completed to deploy encryption in the cloud. These include learning about and working with encryption capabilities, including the techniques that may be provided by the cloud service provider, determining the encryption keys. I'll talk about the encryption keys in a little bit. Where are they stored? Because when you encrypt data, you lock it, and there are some keys that are involved in the encryption of that data or locking it. Where are they going to be stored? Consider the cost, because those encryption costs some money. What is the cost involved with each of the available options for securing the data? There is the CIA triad, which deals with confidentiality. Data can only be viewed by its intended recipients. So confidentiality should be ensured. Only those who are intended to view the data should be viewing it, not no one else. Integrity deals with modifying, ensuring that the data is not modified as it is in motion, as it is moving from one point to another. And then it should be accessible to the intended recipient when needed. In other words, when the people who want the data want to view it, it should be available to them. Encryption protocols use mathematical code called a cipher to do the scrambling of that data into a format that can only be read by reversing that cipher. So there are different encryption. There are two main encryption categories: the primary key encryption, private key encryption. So I'll talk about the first one here. Data is encrypted using a single key that only the sender can knows with the private key encryption. So we did talk about storage of the keys. And then the public key encryption, which is also known as the asymmetric encryption. In that situation, data is encrypted with a private key known only by the user. This is not shared with anybody else. That is what is used to encrypt it. But when it comes to decrypting it, it's decrypted with a mathematically related public key that can be made available to the public, as the name signifies it. So this is a public key. So the public key encryption uses two keys: private key, only the user, and then the public key, which can be shared with everybody. There are protocols that can be used in securing the cloud infrastructure. There's the secure sockets layer, transport layer security. These are two common encryption protocols which are used to encrypt communications across the internet. So each time a client and a server establish a secure sockets layer and transport layer security, they generate a unique session. And then, of course, a session is created by a handshake protocol. You may recall how TCP works with these handshake. It allows the client and the server to introduce themselves to each other and establish the terms of how they will securely exchange the data. So that handshake has to take place. But you can also use the command line interface utility OpenSSL to troubleshoot issues with SSL and TSL encryption. So there is an example of TLS. That's a more secure option for encryption. Then there is DNS security. DNS messages are sent unencrypted. DNS, not just unencrypted, but unauthenticated by default, because this is a UDP-based protocol. UDP does not have those handshake that take place with TCP. So the DNS messages inherently are not encrypted, they are not authenticated, but there are some solutions that can be put in place, like DNSSEC, DNS security extensions. It requires verification of DNS records using public key cryptography. And then there's encryption DAT, DNS over TSL, DNS over HTTPS. Those are two encryption protocols that can be used to ensure that DNS, which is used within networks, is secure. NTP, network time protocol, which is used by different devices to synchronize the time. It doesn't provide any authentication, so there's no authentication associated with NTP, but it can be secured using TLS as an authentication mechanism in a standard called NTS, network time security. Right, another time for a knowledge check before we move on to the last part. How many keys are required for asymmetric encryption? You may recall there were two types of encryption. The public one, which also is also known as asymmetric encryption. How many keys are required for asymmetric encryption? 2 keys. So asymmetric encryption, also called public key encryption, requires the use of 2 different keys. The other one to encrypt and the other one to decrypt. Okay, so now we'll move on to the last part, which is troubleshooting cloud security. Security issues carry significant risks to a company. So this section will talk about common security troubleshooting scenarios that you might face when managing cloud resources. All cloud security techniques rely on proper configuration and consistent maintenance. So this goes not just for cloud, but even on-prem. The resources have to be properly configured and maintenance has to be consistently done. So it's important to ensure that the devices are properly configured. If you're going to configure an firewall, make sure that the rules are properly configured. You are allowing what's supposed to be allowed and denying what's supposed to be denied. And when traffic fails to arrive at the intended destination, problems happen because of these reasons. A misconfigured or misapplied security policy or access control list, ACL in a firewall or NSG, a misconfigured or failed security appliance, right? So notice that configuration is coming, or incorrectly administered microsegregation. There are tools that can be used within the cloud to help protect the cloud resources by confirming best practices are applied to resource configurations. AWS offers the trusted advisor, right? So there is, you can see the trusted advisor recommendations like MFA, the same things, IAM, identity and access management, So below is a list of some of the security weak spots that you may want to avoid. Unencrypted data and unencrypted communication. So make sure that the data is always is encrypted. Same thing goes with the communications as well. Weak or obsolete security technologies. I know there was a story recently about some protocols, point-to-point tunneling protocols. Those are no longer supported. If you have systems that are using those, then you may want to move away from them because they are known to be weak. Incorrect hardening settings, security device failures, your firewall might fail, insufficient security controls and processes, unauthorized physical access. So you want to make sure that the physical access, well, the cloud service provider is probably going to be dealing with the physical access. Data misclassification. The data has to be classified correctly. Key management. To support the public key encryption in the cloud, you must store the private keys either on-prem or in the cloud through a key management service, right? So this has to be done properly. You still might encounter certain issues such as unavailable keys, failed connections, or encryption failure. And you can, to fix key store problems, confirm that needed keys are configured as available instead of unavailable or deleted. Time for our final knowledge check. What security technique can protect inappropriate exposed data, right? So data can be exposed, but what technique can protect that inappropriately exposed data? Encryption. We've been talking about encryption. Encrypting data can mean the difference between a learning opportunity and a career-breaking crisis. So this can really break your career. Make sure you use encryption. That will take us to the end of this module. And please, as I mentioned, be sure to come back and watch the labs that I'm going to be going through in terms of configuring different devices, security devices within the cloud that can help with improving security. As always, thank you for watching. Be sure to like and subscribe so that you are informed whenever I have new recordings. Thank you. That would be all for now.